This lesson is on permutations and combinations. It's lesson 12.2 in your Algebra 2 book. I thought we'd start with a puzzle that some of you might be familiar with. It's called the jumble. Essentially, for each one of these words that's given to you, you have to rearrange the letters until you make a word that makes sense. I'm not so much interested in the answer to the puzzle as I am figuring out how many possible ways are there to rearrange these 5 letters in an attempt to create a word. I think I can convince you of ways to count this without actually writing out all of the possible choices. You could do that, and you're welcome to, but it might take a while. And I want you to think about it this way. First of all, how many choices do I have for that first letter? Well, it could be G or N or A or R or T. That's 5 different choices. It could be G or N or A or R or T. That's 5 different choices. Once I've picked a certain letter for the first one, whatever one it may be, let's say I pick R first, how many choices remain for the second slide? Well, in this case, it can't be R anymore. It has to be G, N, A, or T, and there's only 4 choices left. And once you pick that second one, let's say we picked T. Obviously, we're not making a word. But there are 3 choices left, G or N or A. And after you pick the third one, there's only 2 choices left. And after you pick that, there's only 1 choice left. Okay, and this is how we determine the number of possibilities. 5 times 4 times 3 times 2 times 1. And if you're unfamiliar with this, it's a good time for me to point out, this is what we call 5 factorial. It simply means multiply this number 5 times every number or every integer less than that until you get to 1. And 5 factorial is 20 times 3, 60 times 2 is 120. Now, directly underneath Grant, or I tell you what, by the way, if you haven't figured it out yet, the answer is Grant. Let's move down to the third one here. It's got 6 choices. And so, as you can imagine, this is going to have 6 times 5 times 4 times 3 times 2 times 1 options, which is 6 factorial, and that's 720, a lot more choices, or a lot more possibilities if you have just one more letter. Let's look at this one. And by the way, if you haven't figured it out yet, this is thorny. What about this word right here? You might be tempted to say, well, it has 5 letters, so it's going to be 5 factorial, which is 120. But I want to point out to you that if you can't tell the difference between the O's, the one that's given to you, Croco, looks the same as this. Can you not tell that I switched to the O's? And so what you're going to run into is you've counted twice as much, and so you would have to divide 120 by 2. Actually by 2 factorial. If there were 3 O's, you would have to divide by 3 factorial. By 3 factorial. If there were 2 C's, you'd have to divide by another 2 factorial. But in any case, 120 divided by 2 factorial is 60. Okay, for this right here, it would be 6 factorial. Well, there are 2 D's, so I have to divide by 2 factorial. So it would be 360 options. Okay, all right, so you want to take notes, I'm sure. What we just did, both of those were called permutations. A permutation is simply an arrangement of objects in a certain order. I need to point out that the placement of these objects is dependent. Okay? Unlike the fundamental counting principle, which requires independent placement, a permutation, or independent choosing, permutation is dependent and the order matters. Okay? The order matters. That's extremely important. Okay, if you take all of the objects at once, like when we tried mixing around the letters in a word for a jumble, that's called, that's a permutation, P, N, N, and the way you figure that out is in factorial. This is in your calculator, and it's very important that you pick this up. You can do this in your calculator. If I want to do 5 objects, like the 5 letters in the word Grant, and now I want to do a permutation, I hit the math button. and I'm going to scroll over to PRB for probability, and you see NPR, that P stands for permutation. So I'm going to hit 2. 5 is the total number of objects, and then I'm going to pick 5 of them, and choose 5 is 120. It's pretty sweet. Calculator does it for you. Now, if you don't take all of the objects, so that's what we have in this second case here, then this is the formula. This is for a permutation with n objects. We only choose 4 of them. So let's say that we wanted to make 3-letter words out of the 5 letters of the word grant. In that case, we would do 5 math probability NPR. If I only pick 3 of them, there's 60 possibilities. Okay, and so again, our calculator can do this for us, and it's quite convenient. An example, a math teacher needs to place 5 books on the shelf. Notice that each one of these 5 books is different. There is no repetition. Is the process of placing the books on the shelf independent or dependent? Well, I think you'll agree with me that if she puts the advanced math book up there first, she can't put it anywhere else. Moreover, no one else can go first. So these are dependent events. How many ways can the books be displayed on the shelf? This is a permutation because the events are dependent and the order does matter. And so I know it's a permutation. She has 5 books to choose from, and every single one is going on the shelf. It's 5 choose 5. We've just done that. We know how to do that in the calculator. We get the 5 NPR 5. Or if we wanted to do it by the formula, it's 5 factorial. In any case, the final answer is 120. Okay, a high school honor society is composed of 7 students. How many different ways can they all stand in a straight line for a picture? So we're taking a picture. This is, again, dependent events. You can't be first and fourth. So we have dependent events. And because we're lining them up for a picture, the order certainly matters. That means it's a permutation. There are 7 people in the society, and we're going to put everyone, all the members in the picture. So this is going to be a permutation. 7, and then I can type in NPR 7, which is just going to be 7 factorial, which is 5,040. Okay, and it says how many ways can they select a president and a vice president, assuming that one person cannot hold both offices. So this time, we're choosing 2. It's important. So they're dependent. You can't choose the same person for president and vice president. And again, the order matters. Because we'll say the first person you pick is going to be the president, the second person you pick is going to be the vice president. So since the order matters, it's a permutation. There are 7 people to choose from, but I only have 2 offices to fill, and so it's going to be choose 2, 7 NPR 2, and the calculator is what you'll punch in, and that's going to be 42. If you want to do it by the formula, it's going to be 7 factorial divided by 7 minus 2 factorial, which is 5 factorial. There are 42 different ways. Okay, so the word middle and the other word crook, we overcounted in those cases because they have 2 O's or 2 D's. So here's how we change the formula. So a permutation, when we put everything in line, is n factorial. We're simply going to divide by however many repetitions we have. Consider, for example, 5 pens. If I have 2 blue pens and 2 black pens and 1 red pen, I'm sorry, you don't get to see the first part of this question. So it's 2 blues, 2 blacks, and 1 red pen. If I want to know how many ways I can arrange them, well, it's dependent, because if a blue goes first, a black one can't go first. And the order matters because we're talking about how to arrange them. We know it's a permutation. But because I can't tell the difference between the black pens, I can't tell the difference between the blue pens, this is one with repetition. So there are 5 objects. I'm going to put 5 factorial on the top. There are 2 blue pens, so I have to put 2 factorial on the bottom. And there are 2 black pens, so I put another 2 factorial on the bottom. Now, if you're going to punch this directly in your calculator, you have to be sure to put the bottom in parentheses, or you're going to get the wrong answer. And the other thing I wanted to point out is 2 factorial is just 2 times 1. So those are both 2 on the bottom. But if you insist, you can, 5 math. I am going to do 5 factorial in my calculator. But I know that 2 factorial is just 2. And I know that the other 2 factorial is just 2. So there you go. So there are 30 different ways to arrange those pens. How many 12-letter patterns can be formed from the letters of the word cosmopolitan? Again, this is dependent. Again, the order matters. So I know I have a permutation. I have 5, 10, 12 letters, so I'm going to have 12 factorial. But you'll notice that I have 1, 2, 3 O's. I think that's the only letter that shows it twice. And so I need to punch that into my calculator. 12 factorial divided by 3 factorial. Some of you might have realized at this point, 12 factorial divided by 3 factorial. 3 factorial is 3 times 2 times 1. That's just 6. Okay, and so the answer is 7,983,000. Oh, I'm sorry, 79,833,600. That's a lot of different ways to rearrange that word. That would be a difficult jumble. How many 11-letter patterns can be formed with the words repetitions? Okay, so again, dependent, order matters. 11 letters, factorial. Now let's see. I've got 2 E's, so I'm dividing by 2 factorial. I've got 2 T's, so I'm dividing by another 2 factorial. And I've got 2 I's, so I'm going to divide by yet another 2 factorial. You've probably figured out 2 factorial times 2 factorial times 2 factorial is just 8. Not 8 factorial, it's just 8. So I've got 11 factorial divided by 8. Okay, a much smaller sum, 4,989,600. We're not going to write all those out. Okay, so a permutation is when the order matters. A combination is going to be when the order doesn't matter. It's still dependent events, but the combination, the order does not matter. Okay, so it does not consider order. This is how we write it. Your calculator, you can use the NCR button. You've probably seen already it's directly below the NPR button. It's kind of difficult to keep up with this formula, but it's possible. Okay, Popular Magazine picks 15 top-rated movies. They want to pick 3 of them. Okay, so you can't pick the same movie 3 times. That would be silly. They don't say anything about the order that they're going to play in, so we're going to assume no order. And so this is a combination. I have 15 movies to choose from. I'm choosing 3, and that's how it goes. It's ready for the calculator. I can just type in 15 NCR 3. Or if you insisted on using the formula here, on top you're going to have 15 factorial over n minus r. Well, that's 15 minus 3. 12 factorial over r factorial. That's 3. Okay? I think I can do this one in my head. The 12 cancels out everything. It leaves you with a 15, 14, and a 13. And you divide it by 3. That's going to be 5 times 7, 35 times 13, 350 plus 105, 455. Okay, you can check my math later. Okay, okay, so we're going to kind of do a problem now that involves combinations and permutations. We've got to keep this stuff straight. Okay, 10 names on the ballot for senior class officers. 4 are going to be selected for a committee. Now, we're choosing 4 for a committee. We don't really care which order we pick them in because they're just going to be committee members. So it's dependent because you can't pick the same member twice. And the order doesn't matter. It doesn't matter. You're going to be on the committee if you're picked first or if you're picked 4th or 3rd or 2nd. So no order. So we're going to do a combination. We have 10 people to choose from. We're picking 4. It's 10 choose 4. So I can type in my calculator 10 math probability NCR 4, 210 possibilities. Now it says, how many ways can a committee of 4 be formed if each student has a different responsibility? Well, different responsibility, so it's still dependent, but this time the order is going to matter. Let's say if you're picked first, you're president, and you're picked 3rd, you're going to be treasurer. So definitely the order that you're picked matters. So we're going to say order matters. That means this is a permutation, not a combination. Still have 10 to choose from. We're still just picking 4. And let's plug this in the calculator. 10 math permutation 4. 5,040. A lot more. When the order matters, the number of ways goes up. And then finally, if there are 6 girls and 4 boys on the ballot, how many committees of 3 girls and 4 boys can be formed? Okay, this one's probably the most difficult. All right, we're going to pick 3 girls and 1 boy. 3 girls and 1 boy. Okay, so both of these problems were dependent. If I picked one of the students, I couldn't pick that student again. It affected my next choice. In this case, I want you to realize that picking girls and picking a boy are independent choices. If I pick Sally, that's not going to change which options I have for the boys. So this is independent, so I'm going to have to use, for at least the beginning part, I'm going to have to use the fundamental counting principle. So it's going to be the number of ways I can pick 3 girls times the number of ways I can pick 1 boy. That's going to give us the answer. The number of ways to pick 3 girls. Okay, well, if I'm just talking about girls, then my choices are dependent. Once I pick 1 girl, I can't pick her again, and it affects my choice of the other girls. Okay, so the order for this specifically, for the number of ways to pick 3 girls, this is dependent, but this is just a committee. The order does not matter. There's no order. Okay, so this is a combination. I have how many girls to choose from? Again, I'm just picking girls. Well, there's only 6 girls to choose from, and I'm picking 3. Next is multiply. Number of ways to pick 1 boy. Well, this is another combination, but it's quite simple. If there's only 1 boy, I can only pick 4. And we can just use the calculator here. 6 probability combination, choosing 3. So that's the number of girls, and we're going to multiply that by the 4 boys. 4 ways to choose a boy. So that's 80. Okay, when we do permutations, there's an interesting scenario that pops up if we are in a circle. So you might imagine this is a charm bracelet, for example, and each letter represents a different charm. All of these, while at first they appear to be different permutations, since there's not really a reference point on a bracelet, they're all the same. And so what you might think would be 6 factorial ways to arrange the charms, well, you need to divide it by this number, which is 6. And so what you end up with is 1 less factorial. So this is how we do circular permutations. Now, if there's no reference points, if there is a reference point, you just treat it like a linear permutation. Martha's at a picnic that has a circular revolving condiment server. 5 condiments are placed on the table. So this is circular. There's no reference point. We're going to treat it like a circular permutation. It says, how many ways can the condiments be arranged? Well, we're going to subtract 1 from 5. That leaves us with 4. And we're going to factorial that. So the answer is 24 different ways. The big one, The Price is Right, has 20 numbers. How many arrangements of the numbers relative to the pointer are there? Well, when you have a pointer, then that means there's a reference point, and we can't treat it like a circular. We're going to have to treat it like a linear permutation. So it's just a permutation. We have 20 numbers. We're choosing all 20. It's 20 factorial. I'm not even going to bother punching that in the calculator. It's an absurdly large number, and 20 factorial is perfectly accurate. You need to write this down. Hopefully you've already written down some notes today, but this is how we count. This is all the ways that I'm going to teach you, or that you're going to learn how to count. The first question you have to ask, are these independent or dependent? If they're independent events, you use the fundamental counting principle. You simply multiply stuff together. If they're not independent, you have to determine if it's permutation or combination. If the order doesn't matter, it's a combination. It's ready for the calculator. If the order does matter, it's a permutation. If it's a plain linear permutation, where you choose all or just some of the elements, it's impure. It's ready for the calculator. If you use repetition, it's going to be the total number divided by the repetitions. And then finally, if it's circular permutation, this is your way to go. This is what you need to memorize. This is how you count. Anytime you're asked the question, how many, do not respond with numbers. Instead, respond with these questions. Okay? That's an order. This is your homework. Good luck.